I want to convince you tonight that that is a good thing. Whoops, well, that isn't a good start. Does that work? Yes. Whoops. There we go. So aging gets a bad rap. There are pervasive negative stereotypes in our culture that remind us on a daily basis almost that aging comes with memory loss and other kinds of things. This is Gary Larson cartoon that was one of my favorites, where he's just about to, Superman is just about to go save the day, but he turns to Lois, who's in her later years, and says, dang, where was I going? So, it's what even happens to the best of us. Here's another one. This is Nancy Drew in her later years, Nancy Drew in The Missing House Keys, Nancy Drew in The Secret of the Computer. So I'd like to collect these things because they're kind of hilarious, and I'm sure you have your own. So there's a grain of truth to those silly cartoons, but it's actually much more complicated than that on at least two counts. And one way in which it's more complicated is that there are some abilities that show declines, but on average, these abilities show declines. But there are many others that show stability and growth. So these are data from Hartshorn and Jermeen's Test My Brain project, which is kind of a cool way to collect data. You can go to testmybrain.org and you can contribute to data points in Laura Jermeen's work. But these are data from over 10,000 people that logged onto the website and took kind of standard laboratory tasks that many of you might be familiar with. The digit symbol coding, for example, is a speed of processing task. So you have to, given a coding system of letters and arbitrary symbols, you have to transcribe some a code, and it's really just psychomotor speed. How fast can you process new information? And that does show pretty pervasive declines. It peaks at about the age of 20, and it's all downhill from there. Sorry. But other things like vocabulary and what's not plotted here, like world knowledge and some other things we'll talk about, they don't seem to peak until really, really late, if they ever peak. So maybe the 60s or 70s. So so there are other things in between. So you could think about there's not one, cognition is not one thing. It's not a unified monolith. There are different aspects of cognition that develop differently. So there are declines in what you might think of as mental mechanics, things that are driven by very fast pattern recognition and working with unfamiliar patterns and memory, things like that, so-called fluid abilities. And then on the other hand, there's growth and stability in things like knowledge and verbal ability. And these are the things we call crystallized abilities. So this pattern that you see, this multidimensionality in cognition is rife within the literature. So these are data from our lab. So the Jermeen data went up from, this is from kids up to age of 70, and we went beyond that. So this is like about 65 to 85, and you see the exact same pattern. Is the vocabulary and verbal ability shows great stability and often growth, whereas things like speed, reasoning with nonsense kinds of things, divergent thinking, which is creativity or ideational fluency, visual spatial processing, and memory, those do on average show declines. But it's not just general world knowledge and vocabulary that show growth. Those are just the ones that are easy to measure in the lab to put everybody on the same yardstick. What's harder to quantify and look at more generally are the ways in which we grow through in particularized knowledge and expertise. And these are just a handful of examples of the types of expertise that have been studied in this area. So I ran out of room, but in all of these areas, typing, identification skill in medical technology, pilot performance, music performance, even memory, if you're an expert in that in that domain, if you've practiced those skills within a domain, they tend to be preserved or even grow so that you can outdo younger adults who are novices. The thing about that is that it requires years or even decades of deliberate practice. So one thing you really need to develop these things is time. So to just reiterate, there are two kinds of, cognition's not a monolith. There's actually two sorts of cognition. One is mental mechanics or fluid ability, which are driven by more primary aging processes, senescence processes, if you will, that are more, controlled by a genetic clock. And the others are knowledge-based and crystallized abilities and expertise, and these are more experience-driven. So there's always kind of a race between these two. Okay, so the other way in which the aging story of decline is more complicated is that it's even, whether it's crystallized or fluid abilities, there's a lot of variability between individuals and at any one point in time. And there's also variability in how people develop. Okay, so these are data from our lab. These are exactly the curves that I showed you before here, but I've pulled out each one in a separate graph, and I've plotted the 10th percentile and the 90th percentile. And what you can see is that even though these decline, these all look like declines. That other graph looks so dismal, but what you see is there's also a lot of variability. So that take something like reasoning performance. There are some older adults that are performing at better than the mean of the younger adults. So, or the younger older adults. So there's just you can't downplay the fact that the differences between people are often greater than the average age trends that you see. So that's really important. I just want to show you this in a slightly different way. The graph I showed you before was based on cross-sectional data, where we're looking at people of different ages at one point in time. I have to say hello to my niece. I see my sister and niece in there. So hi, hi fam. These are longitudinal gradients. So these are following individuals across time. And the technical term for this is a spaghetti graph. It's a spaghetti plot, and it looks like spaghetti. It looks like you took a pile of spaghetti and just dropped it on your counter. So there are a lot of people that are stable over age in the individual lines, and there's some that show these declines with time. But the variability, if you plotted the average, it would be very misleading. It's misleading in a sense because you miss how much variability there really is. In the graph on the right is another example. These are from our lab. This is spoken discourse memory. So this is a fairly important ability, is how much you remember from what from a story you've heard, this is relative to, this is showing change from a baseline age, and again you see more variability than age trends. So I just want to convince you that we age differently. And one final slide on this is that this is also from our lab, and it kind of puts the 2 points together, that different abilities age differently, and that there's a lot of variability among those. So this is the red line is print exposure. It's a measure of how much you've learned from what you've read, or basically it's measured by author recognition, which predicts a lot of other things that are important. And that shows steady increases with age, whereas the working memory, which is the ability to hold things in mind while you remember other things, which is an important mental skill for doing a lot of things like reading and reasoning and giving a talk under stress. So some things go up. So again, you've got an example of in the same sample of two kinds of abilities that are important for everyday performance, and they're if you look at the growth and declines, it's kind of a wash, and the variability between individuals can be much greater than the average differences. these abilities are important, and navigating everyday life takes both kinds of abilities. So this is a plot that Salthouse put together some years ago, but I just love it. What he did was he took the norms from the Wechsler Adult Intelligence Scale, and he plotted the ages, the proportion of people at different ages who were in the top 25% of reasoning ability, right there. And so people that are younger are more likely to do better. The people that are more likely to do better in IQ tests and reasoning are tend to be younger. But if you look at the ages of people who are running the world, who are running companies, this is Fortune 500 CEOs, but you get the same kind of thing if you looked at professors in universities and judges and accomplished people who are doing things that they tend to be older. So the Fortune 500 CEOs tend to be in their 50s and 60s. So in some ways, I mean, it's not that these crystallized abilities are kind of the booby prize, which is the way I kind of think we talk about those. To talk about this difference, it's really a genuine gift that comes with aging. So why embrace your aging mind? Well, one important reason is that aging gives you the opportunity to know stuff, and that makes a huge difference in your everyday life. Okay, so that's a really important point that I want you to take away. Let me stop real quick and see, is there any are there any questions I should take, Danny, or clarifications, or can we wait?
I think so far there's been some talk about like positions that people can hold as they get older. Like someone said that there's no 85-year-old pilots, and then some people said that actually general aviation pilots can actually.
Yes. Yes. Yeah, that's a good point. Yep. It is possible to study those people, and that's actually kind of a political hotbed because the FAA would like to take pilots out of the planes because they're worried about aging, but National Institute on Aging, that funds a lot of the work showing, has funded a lot of great research showing the benefits of age, have kind of want to know more about what the advantages are. We all have we know about the story of Sully, who, at the last day before retirement, landed the plane in the middle of the Hudson River and saved the day. So yeah, that's a good point. Okay, I'm going to keep going. Okay, so lest you may think you're too optimistic, we don't want to be too rosy. We want to know, what we don't want to completely dismiss those declines. The declines are worrisome because cognitive declines in late life can be profound. Between 1990 and 2016, the number of people diagnosed with Alzheimer's doubled. In the US, in 2019, 5.8 million individuals were diagnosed with Alzheimer's, and the likelihood of Alzheimer's increases with age. So in the US, about 3% of adults aged 65 to 74 have AD, but almost a third of adults over the age of 85 do, and that's a very large number. There's currently no cure. And Alzheimer's is preceded by a period of decline that has been characterized as mild cognitive impairment, which you can see over here. And so that they're behavioral markers that can manifest really much earlier in the lifespan. So it used to be thought that the biomarkers like amyloid plaques around the cell bodies and tangles in the cell bodies determined pretty much or contributed greatly to the manifestation of the behavioral changes associated with Alzheimer's disease. But now we know that there's something called cognitive reserve. It's more of a descriptor than an explanation, and we're still working on an explanation. But some people who are so the way to examine the plaques and tangles. The way to find out if those biomarkers are there is only at autopsy. And so what we know now is that people that are at autopsy, people that were functioning quite well, that appeared, quite cognitively healthy, also can have these plaques and tangles, but they tend to be the people that have experienced more education, have engaged in complex work, who've read more books, and all that kind of thing. So it's not, so the biology of this Alzheimer's is not necessarily determined. So I'm trying to get to the right screen here. So this one on the left, the figure on the left kind of shows that there's aging, and then there's this preclinical phase of aging that can lead to dementia. And it's not, so dementia is caused by disease processes, but there are a lot of lifestyle factors that can overcome these disease processes. Here's a figure that, sorry for that, I guess it's a nice thing that we're not in a big room. You can actually squint on your computer and look at the screen. But this shows the risk factors and protective factors across the lifespan. So early life education is protective against Alzheimer's and late life pathologies. Hypertension in midlife is an example. I'm not going to go through all of these, but there are a lot of things that you can do to where you can take some control over your fate. So even though there are declines, but to some extent, these risk factors and protective factors are distributed across the lifespan, and there's a lot we can do to take control of that. And there's a lot of interest right now in what we can do to put ourselves on a positive trajectory of cognitive health. There are lots and lots of popular books. And the one way to think about this, this is from a schematic from an article by Chris Herzog and colleagues that's really been very influential in helping us think about this. But you could think about there being a range of cognitive trajectories that, you could think about the B curve as being kind of the average, the ones we saw at the beginning. But then there's these range of curves, the D through the A, and where A is early life enrichment, education, and good nutrition, and all those things that help us get off to a healthy cognitive start. But the question here that we want to talk about tonight is whether there's a C is possible, about whether there's such a thing as late enrichment. Can you've heard the aphorism, use it or lose it. So we want to talk about what do we mean about, how can we use it in order to not lose it? And what is that? What is that it exactly? There's actually a lot of kind of snake oil out there and kind of nonsense that's around. And so you've got to be a little bit careful when you look around into the popular culture. This is a book that you can actually buy this on Amazon. Am I going to get this is on YouTube, right? Am I violating things? This is a book that describes neurologic exercises. So to be if you do these neurologic brain exercises that will exercise in your brain in a certain way, it will protect your cognition. So the idea is to involve different parts of your senses in a novel context, like get dressed for work in the dark. This is one of the particular exercises called brushing roulette. So you brush your teeth with your left hand in the morning and your right hand in the afternoon. And supposedly this activates different parts of your brain, and it's going to just generally make you smarter. Well, I don't know of any evidence at all that would make this a legitimate kind of a pathway to cognitive health, but these things are out there. I mean, I'm being silly, but the premise here is clear. The premise is that novelty alone will prevent cognitive decline. And maybe novelty is a part of it, but that's not all there is to it. It's certainly probably not novelty in how you brush your teeth. This gets to quite a fevered pitch in the area of brain training. There is quite a cottage industry, or not even a cottage industry, quite a large industry on games that are marketed. You pay a fee, monthly or yearly or lifetime fee, which gets to be a little bit expensive, to practice basically what amounts to laboratory tasks that are done, the cognitive tasks that are done in the laboratory. And you could see yourself getting better at those. And the idea is that you're decreasing your brain age as you get better at these particular games. So I was lucky enough to work with this motley crew, and we actually examined the literature, the evidence for the work on brain games. And so it did kind of what we did was a theoretical analysis in terms of brain training, in terms of the way that the practice on those tasks would generalize to other tasks, and did a systematic review and a cost benefit analysis of training, training costs relative to outcomes. And the upshot is that there's really no evidence for the claims that are made by Lumosity and Brain HQ and whatnot for this. You're going to do better in school and better in work and better in your social relationships. So that's not what I mean when I talk about enrichment effects. But I don't want you to think that you don't have any control out of at all. This is another Gary Larson cartoon of the old age truck. Another one of my favorites is, this guy's walking across the street and he just looks up and he gets hit by the old age truck. Wham! And here's his friend with the tire tracks on his back says, "Jim, you too, bummer." so it's like you have no control over it. And again, I don't want to just because brain training doesn't work, that doesn't mean that there are not other pathways. And that's what we want to know about. So there are two broad bodies of evidence that I think speak to this question. One is uses experimental designs that allow for strong causal inferences about the effects of training on particular cognitive skills, and then how building those skills generalizes to other skills. So this way you can allow people to practice very particular aspects of cognition, say visual spatial processing or reasoning or speed of processing, and then you could see the extent to which they build those skills and whether it generalizes to fluid abilities more broadly. And so the question there is whether there's transfer. That's the term. The other body of evidence is whether an engaged lifestyle works. And I'm going to talk about that in a second, but let's just talk a little bit about cognitive training first. So the cognitive training literature has, because you've got such control over the circumstances, because you're doing a real experiment, this has just been very informative about plasticity, about the way in which we can grow abilities over time. And I think the best example of this is the ACTIVE trial, which stands for, and I'm forgetting, but it was a clinical trial that tested almost 3,000 people that were 65 years and up, a very diverse group. They were randomly assigned to 3 training groups, or a waitlist control. So the 3 training groups, one training group practiced the speed of processing. It was really just speeded decisions with some distractors in there. It was another group practiced reasoning. So it was inductive reasoning tasks like the puzzles you probably are familiar with, like 2, 4, 6. What's the next one? Was that they get a little more complicated. So one group did speed, one group did reasoning, and a third group did practice memory strategies. And so they were trained in memory. And the results were could not have been clearer. This is the pre-test to post-test gains in the right in the first at the on the left side of the graph, and speed training and reasoning training and memory training each had quite large effects, especially speed and reasoning training, on the abilities that were practiced. But if you look at all the lines at the bottom down here, there were no effects beyond the thing that was exactly trained. They also followed these people out to 10 years. The study, by the way, the last time I checked, has cost the U.S. taxpayers $30 million. So this has been quite an investment of funds but it's been well worth it because we've learned so much from the active trial. So what you see over time is that the training effects decline somewhat, but up to year 5, speed and reasoning were significantly above baseline, and speed training continued to have an effect, quite a large effect up to 10 years later, but still just on speed. So what this has shown is that is a tremendous amount of plasticity and specificity in training. So the lesson here is that when you build your mental skills, you build them by practicing exactly the mental skills that you want. The other body of evidence is the extent to which we can build mental abilities through an engaged lifestyle. These data are not so clean. These tend to be correlational or epidemiological data that allow a window into real life outcomes. And the question is whether engagement can build cognitive skills. So, for example, does reading books over a long period of time build cognition? Does working out with visiting with relatives after Thanksgiving, does that help your cognitive skills? Does doing crossword puzzles, does staying mentally active and engaged? And I'll give you some more examples in a minute. So let's talk more generally. What I mean by engagement is an investment of personal resources over time. So we could kind of take for a starting point the definition in the Merriam-Webster that defines engagement as binding oneself to do something, to provide an occupation for, to hold the attention of, to induce to participate, to enter into a contest or battle, or to deal with it, especially at length. I think we can distinguish 5 different types of engagement. And I'm going to go through these, but it's not that typically in most activities, there's more than one type of engagement involved. But these are kind of more pure types. They're kind of different types of engagement that are involved in different kinds of episodes over time. So let's define the 5 types of engagement. One kind of engagement that we probably know the most about is physical engagement. That is participation in physical exercise, like aerobic conditioning and strength training, and that is it's among the most investigated, and it's actually relatively easy to do sound experiments to test the effects of aerobic exercise and strength training, and this just no doubt now is that physical exercise is really great for cognition. Art Kramer and colleagues have done a lot of work showing, illuminating the neural mechanisms underneath it. Physical exercise helps produce angiogenesis. It builds boosts blood flow through the brain, and that contributes to building new neurons and some other kinds of chemical changes in the brain that are favorable to cognition. So if you had to pick one thing to do after this talk, I guess I would say go out and join a gym or start running. Maybe not quite running yet; it's getting a little cold. But that's an important aspect. Another type of engagement is behavioral or activity engagement. And this is participation in activities that have the potential to introduce intellectual challenge and novel experiences. But it doesn't necessarily mean that there's a deeper kind of attentional engagement or emotional engagement. So I like this example of a guy on his patio listening to not particularly easy listening radio. And I guess it's a radio station, not even public radio goes this far, but I guess it's calculus equations. So he's showing up, but he's not much more engaged than that. I'll go on. I was going to say something, but I think I'll say that. Another type of engagement is attentional engagement. So this is the allocation of effort to learning and memory and or problem solving. So it's actually being using mental resources for some goal. So this is another Superman who's going to keep his mental abilities by practicing his grocery list. So he's thinking about, he's trying to hold his grocery list in mind. So he's allocating effort to maintain memory. Another type of engagement, fourth type, is experiential engagement. So this is the phenomenological experience of an activity. That is, how do you experience the activity that you're doing? The experience, how you experience the activity engagement, and dispositions or personality or attributes that contribute to the experience of the activity. So things like mindfulness or flow, that sense of getting lost in some challenging activity, self-efficacy, the belief that you will be able to exert control over things, that if you have self-efficacy in your memory, you'll engage in strategies that actually help that, actually are favorable to memory. Openness to experience and novelty, conscientiousness, all of these things have been related to good cognition. So this is, my example here is, not everybody would look at weird parking signs, one that says no parking on this side no parking on this side from 8 to 10, and no parking on that side from 9 to 11. Can he park his car? So Einstein is pondering the mysteries of space and time here. So it takes a certain type of person to take up these challenges, or take up these to experience these things. Social engagement involves cultivation of relationships with other people. You could measure that in terms of how supported people feel, what kind of emotional connection, and to the extent to which they feel like they can count on other people, or social networks, how many people they actually interact with, or doing things for other people. So doing things for social purpose. Those are both examples of social engagement. So at any particular time, multiple forms of engagement can be combined. So in these you can I think of these as kind of silly examples of having social engagement and attentional engagement at the same time. So these are scientists that are being very social, but it looks like they're having, their jokes are, from the guy on the balcony. So in contrast to the guy on the balcony who really wasn't paying attention too much, these guys are actually using those equations. So if that makes sense, any quick questions? Oh, thank you, Danny. Advanced cognitive training for independent and vital elderly. Thank you. If there are no questions, let's see. Okay, so this has all been kind of rarefied, and I wanted to put a little meat on the bones and talk about what the evidence is for any benefits of these. So there are four kinds of evidence that I think we could look at. Cross-sectional correlations, you're looking at whether at the same point in time, people who are more mentally active or more engaged show better outcomes. And in fact, people who stay mentally healthy and socially engaged do better on laboratory tasks of memory and attention. They tend to be healthier, they tend to be happier. But this isn't such great evidence because it's correlational. It could be that the engagement is causing the the intact cognition, or it's just that it could be that people that have better cognitive skills are able to do all of these things. So we don't, there's definitely a lot of evidence for that, but it's not very good evidence. Another type of evidence is lagged longitudinal correlations. So in that case, you're looking at one point in time how engaged people are, how engaged people are, and then looking at the outcomes at a later point in time. And there again, you have some evidence for that. So people who are mentally and socially engaged at earlier in life tend to do better on laboratory tasks of memory and attention later. They tend to be more resistant to Alzheimer's disease, and they also live longer. There are another kind of great example of research on that, using that design is on retirement. So cognitive declines tend to accelerate after retirement, and there are a lot of moderators there. We can talk about it another time. This is better evidence than the cross-sectional correlations, but because it's better evidence because the cause is preceding the effect. But on the other hand, Alzheimer's disease can have prodromal effects. That is, there can be subtle effects much earlier, and so you have to be, real careful to make sure that there's not, to screen out people with illness real early on, so that they're not just contributing to the effect. So it's better evidence, but it's not perfect. Not that any evidence is, but then a third type of evidence is from natural experiments. And these are studies where people have more opportunities to be engaged by things that are completely out of their control. So Roederer and Willis's study, they're economists, of differences among countries was quite informative here. So they found that that countries with tax policies that induce early retirement tend to have populations that show greater declines in cognition between the ages of 55 and 60 or 65. I forgot exactly what it is. There also have been found to be there's discontinuity in cognitive declines that align with changes in Social Security policy. So if Social Security in the U.S. there was a period in time when the age changed, when the age for eligibility changed, and you could show that, and it was shown that declines in nationally representative samples doing cognitive tests showed differential declines around that time. And then finally, there are true experiments, that is, interventions that try to promote a mentally and socially engaged lifestyle. And these are hard to do because it's hard to get people to change their lives. But there's several examples, and I'm going to talk about a couple of those. Okay, so there's the Experience Core, where by Michelle Carlson, Linda Freed, George Reebok, and others. A huge effort over a number of years, where older adults were randomly assigned to volunteer positions in public schools, and they worked with teachers and students, with different kinds of tasks. Some worked in the classroom with the kids, working, helping with homework or helping with reading or whatever, and others worked in the office. They would call home when a kid doesn't show up, and they showed an improved attentional function as measured by certain measures of executive control. So they kind of better able to deal with distraction and respond quickly in a situation. In lab tasks. Another example of this kind of intervention approach is the Synapse Project from Denise Park. They randomly assigned people to digital photography and quilting and different kind of combinations. And the results are kind of complex, but I think one thing that's clear in those data is that working with digital photography improved memory. And finally, the Senior Odyssey project that we did here at U of I engaged older adults in team-based creative problem solving. And I want to tell you a little bit about that. So this was a study that we started over 15 years ago, and it's over now. But we asked a question, and we got an answer. So just to put this into context, given when it was started, I've presented a lot of evidence that's more recent. But when we started this, what really wasn't clear was whether there was any kind of a causal relationship between engagement and cognition. And so just the random assignment to groups of people that did different sorts of engagement was important. And so we kind of threw the kitchen sink at it. So one criticism that you're going to have here is that there's a lot of things going on, and that's okay. That at the time that was important. It was a good thing to do. Okay, so in the Senior Odyssey project, I want to say my niece designed that logo, but older adults were randomly assigned to the creative problem solving manipulation, team-based creative problem solving. So it was based on a program that's been around for a really long time, Odyssey of the Mind for kids, and through college age, and it involves collaboration within teams to get ready to compete in a tournament. And all of the activities are built around creativity and ideational fluency, solving fast-paced problems, as well as longer-term problems like writing plays and building balsa wood bridges that would hold so much weight. So it operationalized what Carmi Schuler called an enriched environment. It added a lot of complexity. It was social. It was it involved a regular schedule. You met with your teams every week over 16 program weeks. It involved attentional engagement. It was a lot of mental activities. There were two controls to test the effect of engagement. One was the training model. So here we're just training inductive reasoning, and we know from the active trial that that should train inductive reasoning. So it was kind of a sanity check. Is this, are we actually able to train, to randomly assign and have that as a benchmark? So that was the group that we expected to do better in inductive reasoning. And we filled in with some crossword puzzles and Sudoku, which we didn't really expect to have an effect, which we talk about later. And then there was a waitlist control. And it was a very large sample, and it took about 4 years to get to cycle through the program. It was run in connection with the real Odyssey of the Mind, the one that's been around for a really long time. And our participants actually engaged in tournaments at the state and national level. So this is an example of some of the stuff that the Troy participants did. We call them Troy and Ithaca, so that they were both parts of the Odyssey. So they both had expected to do better. They were both in the good group. So the Troy program, let's see. So these are all pictures from the tournament. This scene is from a performance where the participants had to rewrite the history of how some wonder of the world came to be. And so it was all about Egypt. They solved the problem. It had certain criteria they had to fulfill. They designed the sets and made them. They designed the costumes and made them. They wrote the script and memorized it and presented it to an audience and before judges. This is an example of the balsa wood problem. Hey, Steve. Good to see you. So this is an example of the balsa wood problem. So the task was to build a balsa wood structure out of it was balsa wood and glue, and it couldn't weigh more than so many grams or whatever. And the way you could test how much weight it held was by crushing it. So over the 16 weeks, program weeks that these wonderful people did this, they were designing it and crushing it and and then rebuilding it to try to get it to hold more weight, and then it would finally be presented on at the tournament. This picture right here is not actually is an amazing team that competed against the college students in Illinois and won and won a special prize, and then went to they won the Omer Award, which is a very coveted award in Odyssey of the Mind. And then they went to the World Finals at Iowa, and they actually won third place. And so they beat out a couple of other college teams for their work. The woman in the front is not one of the team members. She is the Illinois State coordinator, or was the Illinois State coordinator for Odyssey of the Mind, and helped us a lot with the design of the program and training judges and helping us train our coaches and all that. So it was, Joanne died a couple of years ago, and I miss her a lot. She was awesome. Okay, so what do we find from all that? So this shows the change in performance on speed, visual spatial processing, memory, reasoning, and divergent thinking. So, as we would predict it, we would expect, and we predicted, the Ithaca group in the light blue outperformed. That is, they showed more change in inductive reasoning from pre-test to post-test than the other two groups, than the engagement group, the Troy group, and the weightless control. What we kind of didn't expect, what we were really kind of hoping, is by putting adults in this crazy, complicated environment, we thought that all these skills would grow, because it did to some extent require speed of processing and memory and all these other things. But in fact, what we found was a pretty large effect on just divergent thinking, which is creative problem solving, which is creativity. So ideational fluency. So it was really where the Troy participants really grew was in the exact skill that they practiced and was threaded throughout the whole program. So so it wasn't quite what we expected, but what it did show, which is really important, is that you can grow cognitive skills in just everyday activities. And that may be common sense, but it really, I mean, you may have expected that, you may have had that hypothesis, but it's really hard to show that in the correlational literature and in literature that is existing at the time. And so that's a really important finding. Another thing we found in the study was that different sorts of people benefit from different sorts of engagement. So there were greater benefits in the Troy group for those who started with higher levels of openness and larger social networks. And I mean, the effects were quite large. So these effects they're really not that, the effects are, okay, you're good. I think somebody's mic is on. If you could turn that off, that'd be great. But this makes a lot of sense, right? Is that the thing about the Troy group is that it required exposure to a lot of new activities and creativity, and that's the exact personality profile of somebody with openness to experience. So somebody who's open to experience likes novelty, is comfortable with novelty, doesn't like a rut. And that was exactly the kind of engagement that Troy made available. The other thing is that the Troy program was very, very social. which the Ithaca program was not. So the Ithaca program was very individual. So you brought home your packets and you did your activities and you went. So the fact that so in other words, the Troy group grew as people in the Troy group who had the dispositions, the existing social skills, and the dispositions that were matched to that the activity engagement seemed to take better advantage of it. So you could think about this as an example of person environment fit. So you've got, so engagement not only showed that engagement in a program, just doing your, just engaging in things that you enjoy can actually build a skill that's used in that activity, but it shows that it works especially well for people that come in with the right set of dispositions. So it's really important to find the things that you like to do and that fit you. And I want to give you one more example of a program that's of an intervention that's we've finished collecting data. Mainly we've finished collecting data because COVID cut everything short, but we've got our data and we're writing it up now. And so we're looking at the effects of literacy engagement. So one thing you notice about the Odyssey, as I said, it was a very social program. Well, not everybody likes to do that. And some people like to read. And in fact, there are a lot of doctors that say, actually advise their patients when they say, I've talked to MDs who do this, I've talked to patients who say their doctors have told them this, is that if you want, patients ask, what can I do to keep my mental abilities? And they'll say, read books. And there's actually no evidence for that. And so we wanted to test that. There's a good reason to think that literacy could improve cognitive abilities. Education, which is largely literacy based, is the most potent intervention, quote unquote, for late life cognitive health, as you saw from the Herzog little schematic. Poor literacy skill and reduced literacy habits are predictive of cognitive declines. And we know that reading is a self-directed activity that engages executive control functions and induces a cascade of neural activity. So when you read a book, it doesn't just, you don't just see, activation in the parasylvian cortex, which is responsible for sentence processing. It produces a cascade of activation in areas responsible for following goal structures, following visual spatial arrays, and all kinds of things. So, there's good reason to think that reading might be good for you. So we randomly assigned people to a reading club or a puzzle club. They both did these activities on iPads and had log books built into the iPads. And these are our data that we're still writing up. But this shows the standard unit change for people that were, for people in literacy engagement, the literacy engagement group, or the active control who just did puzzles. And episodic memory and working memory were differentially improved by literacy relative to the active control. Verbal fluency, which is the ability to produce what I'm not doing now, is the ability to say, is typically measured by naming category items in a category, but it's just the ability to be fluent, to speak fluently, which I'm not doing now. That didn't show any effects, which is confusing. But it also makes a bit of sense, is that when you read novels that are engaging and keep your attention, there's implicit exercise of both episodic memory, that is, you have to remember the characters, who the characters were and what happened in the plot, a few pages back, and you have to, or chapters back, and you have to use that working memory thing we were talking about, where you have to hold what's happened before while you process the new information. So we're really excited about this, and we're still looking. There's a lot more data to analyze, but that's where we've got so far. So back to our original model. I think I've talked about each one of these in some way. We talked about the physical exercise, the exercise work that hasn't been done in our lab, but there's a lot of evidence for that already. Behavioral or activity engagement is important, but you have to use these other, you have to be engaged with these other kinds of attention, these other kinds of, you have to use other sorts of engagement as well. The reading and the Odyssey project, I think, bootstrapped attentional engagement and social engagement. And we found that experiential engagement can boost the effects of these other kinds of engagement. So I think we've kind of touched on all of those. I was hoping I wouldn't go the full hour, but I think I missed it. But I do, if you want some more evidence for experiential engagement, I've got an appendix with some more data if you want more data, if you're data hungry. So, so reason number 2 for you to embrace your aging mind is that aging gives you the time you need to grow skills and habits of minds to do things you couldn't do when you were younger, and perhaps even to preserve your cognitive health. So it's really up to you. It's your choice. I like this cartoon where he's pondering whether to chase the fountain of youth or the fountain of bacon. The fountain of bacon is drawing his attention right now, but you don't know what he'll decide. And it's not for sissies. It's a serious. You have to embrace aging. You have to embrace the day-to-day experiences of your life to age well. And I want to thank people from my lab and faculty and National Institute on Aging for funding this work. So thank you. I'm going to turn this off. Okay. I'll quit sharing my screen. There. Do we have any time for questions?
So yeah, thank you so much for your help, for your talk. It was really interesting. I have some questions that I had come up with as you were going through that, because it felt really interesting to me. And yeah, if anyone else has any questions, feel free to throw them in the chat, or you can unmute yourself, or if you're on, we do have the YouTube live thing, and I'll monitor that too. If anyone puts questions in there, feel free. Yeah, I guess it sounded like you described a whole lot of different types of brain tests. You can measure different categories and things like that. Are there any that are like more or less accurate or more or less reliable?
Oh, that is a great question. Well, when we do research in our lab, I mean, all of these constructs that I've mentioned, have measures that are more or less reliable, and we work to get instruments that are reliable. So the way you measure reliability is you look at whether the items themselves kind of are doing the same thing, and you can also do retest reliability to see if they're consistent over time. Ironically enough, the things that are the most reliable to measure are the things that tend to be most age vulnerable. So it's really easy to measure speed of processing, right? I can get reliability of like 0.9 with speed of processing, and that's important. I mean, those declines are important. But what I can't do so well as easily is to measure knowledge or expertise. Those are, the more complex skills are harder to measure. So that it puts us in a bit of a bind when we're trying to measure. It's easier to measure things that fluid abilities and crystallized abilities, although vocabulary is very good, but more general knowledge, because we know different things. I mean, that's the thing about getting older and becoming an adult, right? Is that you make choices about the different kinds of things you want to know. And so it's harder to measure that, because if you're an expert in cooking or whatever, if you're a gourmet chef, then, and you have your own particular kind of thing that you like to make, you're an expert at souffles. I don't have a standardized instrument for souffle making, but so it's a gap. Suma, I think you have your hand up.
Yeah, thanks a lot for this awesome talk. So my question was more of, when is it too late to begin working on these abilities, or is any time a good time?
That's a great question. I think any time is probably a good time. It's hard. Obviously, it's easier to get people who are in their 60s and 70s into these studies than 80s and 90s, although we have. But I think the earlier the better, but any time is good.
So there is benefit to doing something rather than doing nothing about it.
Yes, yes, and it's definitely yeah, and it's definitely you definitely don't have the excuse of I didn't do it when I was in my 20s and 30s, and I can't do it now because it's too late. That's like absolutely not right.
Okay, that's good to know. Well, I have aging parents and
Yes.
parents-in-law, so I think I should transmit that.
Thank you. That's a great question.
Okay.
Yeah. I see a question from Jim. You mentioned at the data are noisy. What do you do with wild outliers? And can you learn from the outliers in the data? That's a great question, Jim. You know, we tend to you know, actually what we do, what do we do with outliers with the Odyssey project, is we tend to use intent to treat analyses so that we analyze everybody regardless. And then we do other kinds of analyses. We kind of separate out the subgroups to see if they're different, you know, to see if that makes a difference. You know, so if it's one outlier that's that's pulling it out, then that's important. But they're outliers at different ways, right? At different levels, right? So there are differences in test scores at pre-test, and so you can have an outlier who's doing really well or doing really poorly, and then you can have an outlier with respect to change. So some people will change a lot, and some people will change a little, and you know, obviously, you don't want to take out the person who's changing a lot, or the person who doesn't change, so or shows negative change, so it gets worse, which happens. But you want to analyze for that rather than take them out as outliers. So one thing we find is that people who start out doing relatively poorly on those tasks at baseline are more likely to drop out. And so there's a certain amount of people are in our studies. And so I think in terms of application, what you want to do is when you can engage seniors in these programs, you want to do whatever you can to keep everybody in there, because everybody benefits. I hope I answered your question. Yeah. Yes, Jim. I don't want to say we don't average them. We do average them in, but then we look at them separately as well. More so for the baseline outliers. That's a great question.
Another question that I saw pop up was like, are different types of engagement, do they correspond more or less with different types of like mental abilities? So like the speed of processing or vocabulary?
That's a great question. And I don't think I can answer that question. I mean, I think for like speed of processing, to get good at speed of processing, you have to do intentional, you have to do that kind of a task. I think that's what we learned from the training literature. Whereas for things like, these are hypotheses, I don't have data for this, but things like openness to experience or cultivating that, I think that, or mindfulness or flow, I think those might, or to develop writing skill, those might be more bound up with those kinds of dispositions. Anything else?
Yeah.
Thank you.
If there's no other questions, yeah. Thank you so much for your talk. It was super interesting. I enjoyed it a lot. Yeah.
Well, I'll hang around if anybody wants to check in.
All right.
Thanks.
Yeah.
Thank you, Jim.
And thank you all for joining us. And yeah, we'll start back up in the spring. So I think February is our next Science Cafe date. So hopefully we'll see you there. But thank you all so much for joining us. Thank you.
Thank you. Steve, good to see you.